Energy Pathways is an energy transition company, and what we're doing is we're looking for opportunities that manifest themselves out of the energy transition, and in particular the UK's energy transition.
The UK faces big challenges around energy security and affordability. Where do you see the biggest gaps, and how can MESH help close those?
Yeah, so in the UK energy landscape, there's some key challenges in the way the UK is going about its energy transition, but principally it is the move to a electricity grid dominated by renewable energy, or in the UK's case, principally wind generation capacity. And with that, you're seeing a massive increase in the UK's wind generating capacity, and that is increasingly exceeding demand. So if you look at sort of UK average demand for electricity, it's in the order of 35 gigawatts, and the current footprint for renewable or wind generating capacity is somewhere in the order of that same number, so 35 gigawatts. And with the UK's energy transition, the plan is to increase that wind generating capacity. Government targets are threefold that, so up to sort of 90 gigawatt potential. And all of that's going to happen quite quickly if Clean Power 2030 plans can be met. Now, so already with the UK's wind generating capacity of 35 gigawatts, the UK is already struggling to be able to get all of that wind generating capacity into the grid. So what does that mean? That means that you're getting curtailments occurring, and so curtailments or constraints are costing the UK consumer. Because when the wind blows and the grid can't take that wind generating capacity, then wind farms are paid to shut in effect, and the cost of that bill now is running £1 billion a year, which is effectively passed on to the consumer bills. So we're in the business here of looking to address that, or support addressing that by providing a storage solution. And that's the sort of a key part of the MESH project, is to provide a long duration energy storage solution that can harness some of that wasted wind that the UK is generating, and in so doing getting value for the UK consumer.
MESH has now been recognised by the government as a project of national significance. What does that actually mean in practical terms?
Well, it's a recognition of the project being able to play a critical role in the UK's energy transition, and I've described one of the key pillars of the UK's energy transition going forward. The priorities are developing renewable wind generating capacity, and not far behind that is storage solutions for the reasons we've already discussed. MESH as a long duration energy storage solution is a large scale facility capable of storing energy for long durations of time, so multi-day storage that can then be dispatched into the UK grid when the wind's not blowing.
The S35 planning approval sounds like a major milestone. How does it streamline development and speed up delivery?
So what happens with Section 35 designation as a project of national significance is that the project runs through a particular planning approval process now, and it's essentially the various components of the MESH project are all umbrellaed under a single planning approval process and a development consent order, and the idea behind that is it streamlines nationally significant projects to run through such a process, so it works more smoothly to deliver important projects for the country.
You've said MESH could help capture wasted wind power. How will that work, and what difference could it make to consumers' bills?
Well, so as I've already sort of partially described, the cost to consumers of curtailed wind is currently running at £1 billion a year. the government's own forecasts of curtailment or constraint costs are forecast to increase by 2030 to up to 6 billion to 8 billion. And all of that just gets passed on to the consumer's bills. So any project or facility that enables that wasted wind power to be harnessed and reused will be for the benefit of consumers and will be able to reduce their electricity bills.
MESH combines gas, hydrogen and compressed air storage. Can you explain how that integrated system works and why it's important?
Yeah, so the important aspect here is our principal sort of arm of our energy storage system, long duration energy storage system, is a compressed air system. And the benefit of that and the way we're going about it is that we can do it at scale and we can also do it in a repeatable manner. And so we can offer up long duration dispatchable periods of supply from this system because we can store at scale. So we're looking at multi-days. Now if you compare that, say, for example, with battery energy storage systems as a means of storing electricity, the UK average storage duration from battery energy storage systems is 1.4 hours. And that comes also with a capital cost now. So we think we can deliver multi-day storage at a competitive cost, say in comparison to battery energy storage as a solution. And for example, solutions such as pumped hydro.
You're partnering with some heavyweight names like Siemens Energy, Wood, Costain and Hazer. How are those relationships shaping project delivery?
So we've chosen Siemens Energy as a technology partner for the long duration energy storage system because we see them as the leaders of compressed air storage technology in terms of compression capability and turbine capability and how those systems work. So our partnership with Hazer is around production of hydrogen. We see that technology as being a low-cost hydrogen production technology, and we use that as a means of further decarbonising essentially flexible power gen. So when we dispatch power from the long duration energy storage system, we use hydrogen as a fuel, and that we're using the Hazer production technology, which has been developed in partnership with KBR as a means of generating hydrogen at a competitive cost. We think our hydrogen production capability will be lower cost than blue hydrogen, and it'll be a fraction of electrolytic green hydrogen, somewhere in the order of a third to a quarter of green hydrogen cost.
The project includes hydrogen and synthetic graphite production. How do these fit into the UK's clean energy and critical mineral strategies?
So one of the benefits of the hydrogen production technology that we've chosen, the Hazer production technology, is the way it works is it essentially takes a methane molecule and cracks it and splits it into hydrogen and carbon. Now, in this particular form of methane pyrolysis, which is a technology type, the carbon that is produced comes out as graphite, as opposed to commonly these technologies produce an amorphous carbon black type carbon form. So the attraction to us of that is graphite is a critical mineral to the UK and to actually many developed countries, and there is significant demand and undersupply for graphite. Graphite has been identified by the UK government as a critical mineral as part of its industrial strategy, and recognises that a secure supply chain of graphite is critical to the UK's energy transition. So we're potentially offering up here with our MESH project a domestic graphite production capability, of which we will be the first.
Graphite demand is rising fast for batteries and EVs, as you pointed out. How significant could this become, as a revenue stream for Energy Pathways?
Yeah, so it could be hugely significant for Energy Pathways. So with the Hazer methane pyrolysis process, what we will be doing is producing a high quality form of graphite, and we'll be looking to further purify that so it can become essentially a high grade battery or anode grade battery graphite. Now, the potential value of that could be significant. If you look at the current price of battery grade graphite, you're looking at somewhere in the order of 10,000 US a ton. So we'll be producing in the order of targeting 60,000 tons per annum. So the potential size of the prize could be significant. Obviously, steps in the journey here to be completed, but at the end of the day, graphite is a critical mineral for the UK's energy transition, and it's a key input into the development of EVs and battery capability.
Could you expand on the potential for gas storage with the MESH project?
Sure. With gas storage, we see as part of our offering the ability to store gas at scale, and essentially we have a development ready to go for gas storage and gas extraction, and again in the sort of the UK landscape. The UK's gas storage capability is very low in comparison to other countries. So it's about a tenth of many European countries, and as the UK becomes increasingly dependent on imports of gas in its energy transition, then we think gas storage has a key part to play going forward. Now, the UK's current gas storage capacity is set to potentially reduce. The major asset is an asset called Rough Gas Storage, which is owned by Centrica, and Centrica has cautioned that it may shut that down, and so we think that further exacerbates the need from an energy security point of view to increase the UK's gas storage capability. Now, the role of gas, stored gas in the UK's future energy system, we think is going to become more important. So if you look at it from a point of view that when the wind is blowing, the demand for dispatchable gas power gen or unabated gas power gen, which currently is the dominant supply when the wind is not blowing, the demand for gas is low, but when the wind is not blowing, then dispatchable gas power gen becomes critical for energy security, and so a ready supply of gas from storage and not relying on essentially real-time imports to provide that power generating capability will be essential. So the volatility in gas demand within the UK has already increased with a wide range, and that's set to increase.
MESH aims to deliver clean power, energy security and affordability. What are the biggest hurdles to making that vision a reality?
The main hurdles is there's a lot of parts to MESH, so there's a lot of parts of working with parts of government here to move that forward. But look, at the end of the day, we see the real value of energy transition, and delivering affordable energy solutions is all about joining the dots and integrating energy systems, and that's the opportunity to deliver on economies of scale and synergies, and that's how we're going about the MESH project.
What should investors and the wider public look out for over the next 12 to 18 months as key milestones for MESH and Energy Pathways?
As we progress our various arms of engineering studies and the design of the MESH project, so we'll be updating investors on that, and we'll be moving our way through the development consent order process with the UK government, and we'll be participating in various government support models that promote the development of assets like MESH.